Alright, in this video I'm going to show you how to set up a Python environment for doing signal processing. If you don't know how to install Python and don't know where to go, I recommend going to anaconda.org. Alright, and here we're going to want to go to download Anaconda. Press download here. Choose whatever operating system you're using. Graphical installer. Allow downloads. It's going to take a while for it to download. So why am I using Python in this course? First of all, it's free for everyone to use. You can also freely use it in commercial applications. I like Python as a programming language. It's a really nice and compact programming language. There are a wide range of numerical libraries that are efficient, that are available for Python. Most students are already familiar with Python, so that's another reason. Python also has a built-in single precision data type, which is really handy for signal processing, because using single precision, you're going to be using half of the memory that you would be using for double precision. All right, I can see that it's downloaded. Let's open it on the Finder and install it. Okay. So I'm going to only be using 3 Python libraries for this course: Numpy, Scipy, and Matplotlib. I might require some others, but these are the 3 libraries that we'll mostly be using. And they are readily available for Anaconda. I think they even come with default installation. Alright, now it's finished. The development environment, and then now it's done. Alright, let's move that. Yeah, we've got the Anaconda navigator here. So if you don't have a programming editor, I recommend just using Spider. Spider is pretty okay. I don't personally use it. I use Emacs, but I don't recommend anyone to use Emacs. Emacs is an editor that was developed in the 60s. Alright, there's Spider. Okay, one of the things I like to do is I like to disable the inline graphics. So you go to Python console, graphics, and you change the backend to one of these. I'm selecting Qt5 here. This will disable the inline graphics and give you pop-up windows instead, which I prefer. We can now test. We can test that we have everything. Write a little hello world program. Print hello world. We can print the value of pi using Numpy. We can print the value of pi using Scipy. And let's plot a signal as well. Let's plot a complex sinusoidal signal with a 44.1 kilohertz sample rate. Let's create a vector t using a range of numbers from between 0 and 99. Divide that with sample rate, so this is now in units of seconds. And let's create a complex sinusoid. This course is mostly going to be about complex sinusoids, so let's create a complex sinusoid with a certain frequency, 2 pi times, I'm going to use 440 hertz. So 440 cycles per second, multiply it with time. That's going to be my complex sinusoidal signal. So let's plot it. Plot.plot. This will give me a one-dimensional plot. So I'm going to plot it with units of milliseconds. So I need to multiply this with 1,000. Let's plot the real parts with a color, with a blue color. And let's plot the imaginary part with the red color. These pop-ups are a little bit annoying to me, but in some cases they might be useful because I think it's a help. All right, I can put a label here and say that this is the real part. Imaginary part. I can also label the axis. It's always a good idea to label the axis. Time, milliseconds. Let's label the y-axis. It's always a good idea to label the axis. Amplitude. I can even put equations here. So $sign e to the power of curly brackets I backslash omega t, and show the legend so that we're gonna show the labels, the explanation of the labels, and let's show the plots. All right, let's see what happens if I run this. Run. And it is, it's plotting the signal, and it's showing print hello world. It's got it's printing pi with Numpy and Scipy, and it's making a plot. And you can zoom in if you want. There are many features here are useful. Okay, that's the end of the tutorial. One more thing. All right, so my code, the code for this course, is going to be available on GitHub. So if you want to get any of these code examples, you just need to head over to GitHub/Javierne, that's my username, signal_processing. You'll find most of the examples that I'm going to be using on this course here. And yeah, I'll be uploading more examples as we go along, so keep updated. If you know how to use Git, you can also use the Git command to pull this code. All right, that's the end of this lecture.